right, welcome everyone to the third talk to the fifth edition of the Legacy of Socrates. Just a word, it should have been Amitai doing his talk, Introduction to TDDDD, but unfortunately he had some personal issues, so he cannot do it today. That's fine. We're gonna see with him whether we record it afterwards, so it will be available on the channel, or more likely, he's gonna be present in the next edition instead. So instead, I am doing the talk in this slot, and the conference will finish an hour earlier today. So there will be my talk here, and then Claire talk just after. Okay, I want to talk to you about techniques to tame a legacy code base. So no need to introduce. We've been talking about legacy code for a while. I've personally been working with legacy systems for quite some time. Even back when I was a consultant, I remember I arrived on different clients, and the problem was usually to work with an existing systems, and so it's funny to consider that it's part of our job most of the time, and yet we're not trained to do that. There is so many resources on learning new tools, new frameworks, new languages, algorithm, etc. But how do you work with an existing code base? So I've dig into this topic. I've get into communities that I will mention here, and you're probably part of them too. And I've learned a bunch of techniques. I've tried a bunch. Some of them worked best for me. And from this short list, I took 7 that are different, and these are the ones I want to present to you here. It's a buffet of techniques. The idea is that you may know some of them, maybe some of them you don't know, and you will like 1 or 2 of them, and you will try that, and you will get results. That's really my intention here. So I first need to define what I say when I say legacy code. There are plenty of definitions. Adam gave a different definition earlier. What I mean with legacy code here is profitable code that you're afraid to change. It's not the best definition. Probably more accurate will be valuable code, because as Claire already mentioned to me someday, what if you work for a non-profit organization? But in this case, I want to focus on the profitable code. So my hypothesis is you're working for a company that makes money out of that code, so you cannot get rid of that code. You need to keep it. It pays for your salary. But somehow you're afraid to change it. And here's why. This is a picture of you working with the code base. At least this is how I feel sometimes. So there are a bunch of traps everywhere. The most common ones are non-existing documentation, or eventually but outdated docs. No test, at least the part you want to change, of course, is not covered by tests. And most of all, short deadlines. It's not like you had plenty of time to think about it through and like spend 8 years refactoring the whole thing. No, you need to deliver features, and you keep having that pressure. So what do you do in that case? Because you need to have techniques to resort to if you want to move on. So my name is Nicolas. If you don't know yet, I have this blog, understandlegacycode.com, where you will find most of the resources I'm carrying around and collecting in this place. Here are the 7 techniques. Let's dive into the first one, which is called ADRs. ADR stands for Architecture Decision Records, and it's the kind of documentation that doesn't suck. Not really, but documentation is hard usually because it gets out of date. ADRs, they don't get out of date. This is because the spirit is different. You don't aim to document how the system is working, and that should be evergreen. No, what you do here is you capture a bit more context when you take decisions, when you change the code. You take decisions every single time, but we usually lack the context that was behind the decision that was taken a year ago by someone else, or maybe by yourself, but you forget why you did that in the first place. This is why you would write ADRs. And the greatness of this is you cannot be wrong. You can only add value by explaining why you are doing this. Here is an example from the code base I'm dealing with at work. It was written in May 2020 by a developer who is not here anymore. And that developer took the time to explain a little bit why we never read on the main database anymore. So you see there is a title, there is a date, context. This is the important part of the ADR. You detail why you are taking this decision. So maybe links to issues, maybe links to some documentation. Maybe this is because of what you know today, because of what you're familiar with, because of the constraints you have for your business, of all the technologies, whatever, like everything that justifies the decision. Then you have the decision, which is a detailed version of the title. And finally, the consequences. Also very important. Usually you take a decision to achieve something, but maybe you have other benefits or drawbacks. Like in this case, for example, we will only use the main database to write stuff. But say you want to use if you want to read from the main database at some point, you need to explicitly do that. It won't be done automatically for you. So yeah, when we ever get into trouble later, we did, because of race condition when data was not replicated fast enough, we wonder why is it working like that? And with this document, we were able to understand, that's why. And maybe now we know better, or we have different solutions so we can revisit that decision, or maybe not. You can start now. It's very easy to write them. These are markdown files, so nothing fancy. There is a CLI tool you can use called ADR tools. You can use that. It will do the boilerplate for you. You just have to fill the blanks. You put that next to your source code. So whenever you're searching for text, you may find the content from an ADR, and keep it simple. Like it doesn't have to be complete or fancy. Any ADR you add to your code base, it will help you in the future. So this is an example from the UK Ministry of Justice. Different places out there are doing that. You can find plenty of examples. It's really good. I test that myself, and we're doing that at work, and it's really, really helpful. That was it for ADRs. My next technique is called brain dump. So as we saw with Adam before, behavior and brain, it's very particular. In particular, your brain has a short-term memory, and it is limited. It is much more limited than what a computer can do, for example. So if I give you my phone number, I will usually give you it in chunks, like 3 or 5 numbers, which will be easier for you to remember than if I give you every single digits. We do chunks because it's easier for people to remember less items. The thing is, when you're working with a legacy system, there are plenty of stuff everywhere. You get distracted because, let's just talk about the code smells. You may see a bunch of things you don't like. And you can get distracted very easily because you cannot remember all of these things while you're working. What I say is we're in 2021 now. We have the technology. What if you could put this stuff that you need to remember into a second brain, so you don't have to think about that anymore, and you can focus on what you're doing right now, and you don't get distracted, and you know that you can get back to that brain at any time. This exists already. This is what I call the PNP, and PNP stands for pen and paper. I am trolling a little bit. And you might be wondering if I just seriously advise you to take notes. And the answer is yes, but not just that. Of course, taking notes, you probably do that already, and it's like common sense, this is not a technique. I would say it's just like meditation. Anyone can meditate. The question is, can you meditate? It takes practice to do it properly. It's not just about writing stuff down on a piece of paper next to you. It's about using it to stay focused. So remember my previous example, you're working on that legacy code base. You want to do something. You want to extract a method, or you want to put that code into test. This is what you're trying to achieve. And you will see plenty of stuff in the middle. You will think about improvements you can do while you're at it. Like, I could also invert that if else clause. Having a pen and paper next to you allows you to be hyper aware of what you're doing. Any distracting thought that crosses your mind, you take your pen and you write it down. By doing so, you calm your brain because you know that you won't forget that thing. But this is not the thing you're working on right now. And you stay focused on what you're doing now until you're done, you commit, and then you move to the next thing. Practice working with this that way. It will avoid you getting into a tunnel effect of nothing is working anymore, but you don't really know if you can go back in time or not. When you feel you're struggling with that, dump what you have in your mind on a piece of paper and use that piece of paper to help you stay focused on what you're doing right now. The next technique is what I call overcommitting. Usually you will find micro committing out there. I wanted to call that overcommitting in this talk because I want to insist on the fact that we're not doing it enough. We're not doing enough commits from my experience. So the idea is commit more often and then commit even more often. If you really want to practice, I think it's a good exercise to commit absurdly frequently. It will feel too much, but that's okay. That's the purpose. The purpose is to get you into the habit of doing smaller, more frequent commits. So something you can try. I do have this gym timer. It's really helpful having a gym timer because it's really cheap. Um, you can configure an interval and you put that in your pocket. And for example, every 5 minutes, it will buzz. And I like that because you can stay focused on what you're doing and you get a nice buzzy reminder of, oh, can you do a commit now? Would it make sense to do a commit now? And every 5 minutes, you get that constant reminder. And if you keep practicing that, at some point, it will become a habit, or at least you won't think about it. I do that when I want to adopt an habit like drinking water, for example. And every time it buzzes, unconsciously, no, I would do a commit or I would drink a sip of water. At some point, because you practice this deliberately, you will get to a point where you don't really realize that you are doing smaller commits naturally. For example, if I do extract a variable, I will do a commit right away. And I mean, I keep in the flow. It's not distracting. I'm just used to do that ping pong now. And this is an example of my PRs usually got 4 times more commits than my peers. And this is actually a good thing because here is a comment I received a month ago from my coworker Vanessa. And she told me I was worried that the PR was a bit too big than usual. And she said to me, no worries about the size of your PR. Your changes usually are hard to follow because your commits are really well organized. I don't organize my commits. I don't spend a lot of time reorganizing the commits at the end of before opening the PR. The thing is, I do small commits that are really easy to follow. And so they actually like to follow my diffs by reading each commit diff one by one. And even if there are plenty, they can go through and follow what I did. So I recommend practicing committing more often. It also helps you keep focus. The next technique is a bit more involved. So if you felt like the brain dump and overcommitting are more like general advice, common sense, etc., here is the mikado method, which is the brain dump but with a recipe, with a process. Here is the recipe. First, write down what you will want to achieve. So that could be anything like upgrade the ORM, upgrade the dependency, refactor something, put some code into test, whatever. It can be your acceptance criteria, for example. Then you take a proper timer this time. In this case, I actually like to have a strong timer like that that will ring and stop me. And you put 5 minutes or 10 minutes or 15. I recommend not doing too long. Like 5 minutes is actually good. And then you try to do that within 5 minutes. After 5 minutes, of course, you won't achieve that, because if you were able to achieve that within 5 minutes, it won't be a ticket in the first place. So the timer will ring and it will tell you you could not achieve that in 5 minutes. Here is what you need to do. You need to stop and you need to think about what's blocking you. Why couldn't you do that within 5 minutes? And it's probably because you have a bunch of other smaller steps you need to do first that are preventing you from achieving this within 5 minutes. And what you have been doing this past 5 minutes is discovering these details. So you stop, you write down these sub goals, you attach that to the main goal. And that is very important. You need to revert whatever change of the code you have done so far. Maximum, it's like 5 minutes of work. So it's really okay to get rid of this code change, but it's really important too. That's also why I recommend not doing 15 minutes, because you might be more reluctant to get rid of 15 minutes of code versus 5 minutes of code is usually okay. So you get rid of that and you start fresh with a smaller task. So you pick one of the leaf and you try again. And eventually you will reach a goal that you can achieve within 5 minutes because it's so easy. So when you reach that state, first you will get your dopamine shot of, oh, I did something, and you can commit. So committing more often, this will ensure that your commit contains like 5 minutes of work max. When you have done that, you cross it off, you pick another sub goal and you start over. And you process like that. This is the whole process. You do that and that will progressively make you achieve the main task. From the outside, it will look like you're speed running through the stage. Really, when we look at your commits after that, it looks like you're flawless. You're doing the whole thing in the proper order. And the thing is, it's not because you know better before. It's because every single time you die, you revert back in time a little bit and you try again until you find the perfect way to achieve that goal. And so you avoid the tunnel effect. Let's see quickly how it looks like, because I know it can be a bit abstract when you just read the process. But the first phase is what I call mapping the terrain. It's when you are learning what you need to do. So first you want to refactor, calculate intermediate charges, whatever that means. There is a more detailed version of this in the ticket. 5 minutes cannot do that. But I found that first I would love to do this for stuff, because that will make refactoring the calculating intermediate charges easier to do. I pick another one and I continue. Cannot do that. There are more. I pick another one and I cannot do that within 5 minutes. There are more, etc., etc. As you work, you realize that first you didn't do any change to the code, or maybe some nodes you were able to complete, but no change in the code. But what you have done is very important. You have clarified what actually needs to be done. You have made a plan of how to achieve that task. And this is super valuable because you can stop anytime and you have this whole context back. You can also collaborate on this, but basically now you have a plan. Eventually, at some point, productivity strikes. You have reached something you can finally achieve within 5 minutes. And this is where you will start achieving more and more and actually doing the work. In practice, there is a bit of expansion and then crunch and then expansion. And finally, you will get to a state where you are just crunching through it. And this feels really good, because when you're here, it means that achieving this task is a matter of 5 minutes work. And you can stop anytime and deliver. This is really awesome to stop and ship at any time. There is a book, and I recommend you not to read it if you haven't. Because if you're like me, what will happen is you say, oh, there is a book, I need to read it. So you're going to buy it. And then you have 10 other books to read first. And so you're not going to read it yet. And you will say, I won't be applying this method until I've read the book. Don't do that. Try it with what I just described. Try that at work or on an exercise. See how it works. And then when you have questions, because of course you will have questions, you will have edge cases, this is a moment where I recommend you buy the book and you read and you get the answers to your questions. Also, because we're working a lot remotely now, mindmap.com is personally the tool I use to do that, this graph online. It's the one I found the best. Okay. Hotspots analysis. I will go very fast on this one because actually that was Adam did a 30-minute talks on this. So I'm gonna repeat what he said. Maybe with a different point of view, but it's one of the most powerful techniques I know to prioritize the technical depth and the work that needs to be done. Gist of it, when everything is urgent, nothing is urgent. It's not just about code, it's about productivity in general. People, your business people, their work is to prioritize features, prioritize work. So they should know about this. There is a tool called Eisenhower Matrix that is a simple tool to prioritize things you have to do. You basically have two dimensions, urgent and important. Urgent is about when do you need to do this, like the deadline, and important is the impact of doing it or not. So when you have a lot of things to do, you categorize the things based on are they urgent, are they important or not. And what is urgent and important, this is what you need to start with. What is not urgent or not important, usually you can either do it later, delegate, or even drop it because yeah, that will be cool, but if you do that, you don't have time to do something else that is more important. So if that becomes more important, it will come back later. So this is how you prioritize things to do. But what about technical depth? As I mentioned, static analysis tools, they cannot save you because, so another way to see it is they give you the importance. They tell you how bad the code is, but they don't tell you how urgent it is to address that technical depth. So here was an example of code climate analysis of the React code base a year ago. They had 8 years of technical debt. Not 4,000 years, but 8 years is still too much. They cannot afford to do that. So where do you find the urgency? As I mentioned, code churn, version control metadata. Here is, by the way, the git log command you can use on any Git project. And this command will give you the 50 files that were touched the most often in the past year. So even if you don't use code scene, you mentioned that gitlog is a main goal of finding this information. So you ask for the file names of the past 12 months. That's usually enough. You will remove the fancy formatting. Then you omit the blank lines or any, for example, you could also egrep, so omit the JSON file, for example, if you don't care about these, the markdowns if you don't care about these, etc., etc. You sort them, you count them, and then you sort them again, but this time using the count number, and that will be the number of times this file has been touched. And finally, you pick the first 50. You combine that list with any kind of static analysis metric that you have for these files, and you put that in your graph. And this is another way to represent the hotspots. You have the churn and you have the maintainability score. So this is the Docker engine. I'm not familiar with it. I don't do Go. I don't know. There is a terrible file on the top left. There is a red square, and this file looked terrible. But turns out this is not the file I would work on first. I would first work on the daemon Unix Go, because although it has a better maintainability score, we touch this file every single time, it looks like. So this will pay off a lot. And This will be the best return on investment. If you need to talk to your stakeholders, like business people, on how to spend some time to work on the technical debt, talk about money, talk about return on investment, have a plan, have graph like that. It really helps selling the project of cleaning up the tech debt. Approval testing. This is also not new for you because we had already 2 talks on approval testing at Legacy of Socrates. Barney Diller showed us that. Emily Bash showed us that in detail. So it will take a whole talk about approval testing, and we already did that. But I need to mention it because it's the best technique I know to put tests that are missing on an existing piece of code. Gist of it is what the system does, more important, what it should do. Be careful of the specification that are written somewhere and what people think the system is doing. What the system actually does is what matters. Remember, you probably have no test and you have short deadlines. So before you touch the code, you better add automated tests. Otherwise, you will spend more time either testing manually or crossing fingers, let your user test the change for you, and then you will have to fix some bugs later, and that will cost you much more. Having automated tests is cool, but writing them on existing code takes a lot of time. Approval test is the fastest way you can have to write the missing test on existing code, in my experience. It's a three steps recipe overall. The idea first is to get an output that you can put in a file. So a string, really. Different techniques it depends on your use case, but if your function you're testing returns you some value, take that value, put that in a snapshot in some file. If it doesn't, if it does side effect, it calls a third-party library, for example. Can you spy on this? Can you somehow get a seam, get a reference to this, change the behavior so you don't really call the external library and instead you write into a file, or you collect content like the arguments that you can then store into a file. The idea is that the next time you execute the code with the same context, you get the same behavior. Then you use the test coverage to find the missing inputs. Test coverage is really good for one thing, telling you what you're not testing. You could just look at the code and try to figure out what you're not testing yet, but it's really hard. It's very easier to do that with test coverage. So you get a test coverage report, you look at the report, you look at the red lines. If that's a line you need to change, to refactor, you need to cover it with test. And so you will be able to find that you're missing some combinations to cover that code. But the test coverage, it doesn't tell you if you are testing the lines that are not red. It tells you that you're executing these, but not if you're really testing them. So use mutations to verify snapshots. It's a clever way to say introduce a silly mistake in the code just to be more confident that you have a test that will fail if something breaks with this code. If we go back here, if I want to, I'm not sure if line 17 is actually tested, covered. I would comment it out, or I will introduce a typo in the name just to explicitly introduce a mistake. I run the approval test and I want to see one test failing. If I do, now I am confident that I can mess around with this code and I'm covered. Ultimately, you will be safe, and in practice, you will be safe faster by writing approval test. So when you're safe, now is the moment where you can start refactoring the code because you have this test in place. As you refactor the code, you understand better how things are working. And this is where you will write more comprehensive tests. If you look at this test, for example, honestly, if I need to maintain this test, I don't really understand what this is doing. The test doesn't tell me what the code is supposed to do. And this is okay because the code was here already and I just needed to put a test on it to make sure I don't break the behavior. But as I refactor the code, I will understand how it works better and I will write more comprehensive unit tests and I will be able to remove some of the redundant approval tests when I don't need them. Emily presented some more techniques that you can use. So approval test, you can use the report and keep that actually to help you maintain the code. But I won't cover that now. Here is a link, bit.ly approval testing. You can go here. I've collected a bunch of resources on that technique. And the Legacy of Socrates YouTube channel, you will also find previous talks on the topic. All right. Finally, I want to talk about coding katas. Here is a pixelized picture of artists performing in front of an audience, a show. I'm using this because I want to say that us as developers, when we work on the production source code at work, we are performing. We have deadlines, things is working in production, people are using it. We cannot do just anything and break stuff around. We need to be careful. We're performing our best with what we know. This is not the best moment to learn new skills. And that's also why, because of the short deadlines, people resort to their comfort zone and they don't try new things. So I presented 6 different techniques, but trying to apply them at work on the production code base may be hard. Instead, a coding kata, it's an exercise that is designed so you can practice. The goal is not for you to complete the exercise. The goal is for you to try something, some new constraints. There are plenty of coding exercise to try techniques like TDD, for example, that you're not familiar with, from scratch. Some of the coding katas are designed to help you work with existing code. So when you want to hone your skills on refactoring existing code, putting that into test, trying different ways like to commit more often, the mikado method, practice this on the coding katas. I've listed here 5 coding katas that are very good. If you never tried this before, start with the Gilded Rose kata. And then the other ones are more involved, but you have plenty available. When to practice? If you're lucky, you may have some free time on your own to practice at home, and that's great. But maybe you don't want to, or maybe you can't. For example, I have a daughter, she's 18 months old, and I don't have all the free time I used to have when I was not a dad. So working on the weekend, not anymore. Instead, your company has a training budget. This is a budget you are using when you go to a conference, probably. It's also a budget you might be using to learn new tools like Kubernetes. There's a lot of workshops about that. And I think this is good. But I think you should also consider spending some of this budget not to learn a new tool, a new framework, but maybe to learn all of these techniques that will help you in your day-to-day life, regardless of your employer, because you will have to work with legacy code at some point. So use that training budget to hire a coach. Addy, for example, they are doing coaching for that, and that's a great way to spend your company trainings budget to train your team to work efficiently with such code. And you can use that to, work on these coding exercises, not alone, but with your teammates. If your company culture is not so much into it, one thing you can always do is plan 1-hour meeting every sprint with other developers to work on technical stuff. And what you will do during this 1 hour is practice together on a coding exercise. So really do the work of taking the time to work together and practice your skills. Something I need to mention, code retreats, it's a full day practice and it's usually free and it happens worldwide. There are plenty of events around, especially these days it's remote. So you can attend that. There is a global day in November every year, on Friday and or Saturday. So I really recommend you to have a look at that and to attend one. The people are great, and you will learn a ton of things. And yeah, it's not just the techniques you will practice, but also the interaction with other people. You will learn a ton of things that will make your life easier every single day. That's it. These are the different techniques that I wanted to present to you. Again, it's a buffet. I wish you learn a couple of things, and maybe you want to try something you don't do today. Try it at work. Think about practicing and when to practice. I really think that will make a difference to have a system to progressively improve. It's not about rewriting everything and overnight change. It's more about gradually, steadily improve the situation. And that compounds over time, and you can have great results. Finally, I have a bonus stage. Some of you already subscribed to my newsletter and probably already acquired it, but very recently, I also finalized what I call the Legacy Code First Aid Kit. This is my kit. Um, it's a collection of 14 techniques to quickly and safely rescue code base. I focused on the missing tests, short deadlines situation. So if you look at the techniques, not all of these 7 are presented in the kit. Actually, only 4. The micro-committing, the mikado method, hotspot analysis, approval testing. I go in much more details. I explain when to use them, how to use them, why it works, and I explore a bunch of different edge cases. Total, it's 200 pages. It's an ebook, and there are printable cheat sheets. I'm really happy about this one because at this date, it's my personal understanding and collection of the techniques I know the best and work the best for me. And I think that can help you if you're interested. So I created a discount with this link because like we're organizing this conference. So I wanted to do something, for you and also to thank you for attending and supporting us in doing that. You have been an amazing community. So yeah, I want to thank you for that. And now I will be taking questions. And I'm gonna drink. Okay, so again, if you have questions, you can use the ask a question box and vote for existing questions. And I will be reading them now. We have a bit of a delay if you're not aware. What I'm saying you will hear in 20 seconds. So that's why if you feel that there is a delay between what I say and what you write, it's normal. Okay, first question. Trick question. How often do you commit? That's a good question. I don't know exactly how often, but here is what I do. I practice safe little refactorings as much as I can. So I try to really do refactor and then do the change. And from Martin Fuller's refactoring book, anytime I do refactoring, I will usually do a commit. So sometimes when I extract something, for example, and it can be automated, I would commit every 10 seconds, 20 seconds. Then I would spend a lot of time thinking about the next steps. And if eventually I don't do a small commit because I'm not perfect, and sometimes I do 2 things, 3 things at the same time. It happens. I would use git commit patch or add patch. So I make sure that I understand what I'm putting in the commit. I often worked, and I did that too, with developers who commit everything that has been changed. That's a mistake. That's usually how you get to commit things you didn't intend to. Don't do that. Git add -p is really the command you need to be looking for. Okay. Next question. Do you ensure that each commit is deliverable? That is, should you have to pivot to a new ticket, can you merge the commits and deliver them in the known working state? Thank you. Very, very good question about committing frequently. So ideally, this is what I try to do. As I explained, first I try to refactor the code and then to implement the feature. So when I refactor the code, I really mean refactoring as in I'm not changing the behavior. The code should still work, which means every time I commit, everything should still work and that could be delivered to production just fine. In practice, I have more or less success. It really depends on the code base, and this is where I think it's worth investing. It works best for me if I can get a fast feedback whether I broke something or not, of course. On my personal projects, there are small projects. I control them from scratch, so I have very good feedback from my editor and from my unit test that run constantly. So I refactor, I see everything is green. I know I'm not breaking anything, and I commit directly on the trunk, on the main branch, and I ship that. At work, it's a bit different because we still have mostly integration tests so far, legacy, so the feedback is more in a matter of multiple minutes. So some frequently I would do the work, but without getting the feedback from the integration test, and then I will run them. And sometimes it happens, I realize, oh, I broke something a couple of commits ago. That's okay because I do small commits, so I usually can find where I started introducing the mistake. But I would not say all of my commits then are deliverable. And that's why we keep using feature branches. I just make sure that my team is keeping feature branches small and short in time, like 2 days, 3 days max. So we merge frequently. It's not perfect, but you need to deal with also what you have, and we're trying to improve. Okay. So I hope that was helpful. If you have any other question, don't hesitate to ping me on Twitter. Usually the best way to reach me out is Twitter. Um, yeah, I think we're gonna take a break. I don't see any more question in the chat. Thank all of you. Also, I know there are some people from Legacy Code Rocks community. If you don't know Legacy Code Rocks, you should check out. There is a podcast. So if you're into podcasts, that's great. And there is also a community. There is a Slack channel for people who love working with existing code, and these people have a lot of things to share. So I recommend you go there. And in general, anything I learn, I put on my blog and just on legacycode.com. So you would find a lot of stuff here. Yeah. Thank you, Adi, for adding the link. Okay, perfect. Let's take 15, 17 minutes break. Thank you all, and see you later for our last talk, which will be Claire McRae.